Okay, let's do something with those ratios. The first thing that you're going to do is use it to find side lengths. We can use the trig ratios, SOHCAHTOA, to find unknown side lengths in any right angled triangle if we have two conditions. One, I know an angle, that's the angle of interest, theta, and I need to know one of the sides. If I can meet those two criteria, I can find any unknown side length in a triangle. So these are the steps. I suggest you have that on your cheat sheet. So the steps to find an unknown side length. This is first, I'm going to show it on the Apple calculator. You need to check that your calculator is in degrees mode. And my shortcut for that is finding tan 45. Okay? So I'll open the calculator here. If I go tan 45, and it spits out 1, my calculator is in degrees mode. Because what you're doing is you're doing this. You're asking the calculator to work out what tan of 45 degrees is. And because it's a 45-degree triangle, these sides are always going to be the same as each other. So it's always going to be 1 divided by 1, 2 divided by 2. So what's 2 divided by 2? It's going to be 1. So that's what it spat out there. If I'm going to purposefully put it into a mode called radians, which you're only going to have to worry about if you do methods or spec next year. I'll do tan 45 again. See how my calculator is in radians mode? If I press enter, see how that's not 1? Okay? So for year 10, you need to make sure your calculator is in degrees mode. So in most calculators, you'll see a button that either says degrees or radians. I'm in radians right now. I'm going to press DEG on the calculator, clear it. And so if I'm doing any questions at year 10, before I do any of this, I'm going to go tan 45. If it says 1, I'm in the right mode. Okay? So get that first part down. First step, check your calculator is in degrees mode by finding tan of 45. If tan 45 is 1, you're in the right mode. If tan 45 is not 1, then you need to set it to degrees mode. You usually do that with a button. So get that down to start off with. That's a check to make sure your answers are going to be right. Later when we have time at the end of the year, because you will have time, your timetable gives you extra time and your class is quite fast, so we will definitely have time to give you some year 11 teaching. I'll teach you what radians is about. Right now, no, it's not year 10 work. So just get the way that you check if you're in degrees and radians mode. So how do you actually do the thing? Once you've done the check that your calculator is in the right mode, what do? You do another check. Do I have a known angle? Do I have a known side? If I know that, then step 3, choose the trig ratio out of SOHCAHTOA. That involves the known and unknown sides. And step 4 is rearrange the ratio and use your calculator to find the unknown side. So sometime. Can you get those steps down before I demonstrate how to find x in both of these triangles? All right, let's do A. Find x in both triangles below. So it's asking me to find an unknown side. Step 1, check my calculator's in the right mode. Tan 45 should be 1. So I'm in the right mode now. I can close the calculator. Okay, check. Do I have a known angle in triangle A? Yes or no? I know 61. Do I have a known side? 9.6. Let's label them now, practicing what you did at the start. This was the hypotenuse. This is opposite to the angle that I know. And this is theta here. Choose the trig ratio, SOHCAHTOA, that involves the known and unknown sides. If I've got opposite is my unknown, and if I've got 9.6 as my hypotenuse, which of these, SOHCAHTOA, involves the opposite and the hypotenuse? Huh? So I have sine of 61 degrees is equal to opposite, x, over hypotenuse 9.6. You're not going to like it, but this is a callback. If I have a fraction on one side of an equation, I can cross multiply to get rid of that fraction. What is the opposite of dividing something by 9.6? Times. So x, 9.6 times by sine of 61 degrees is going to equal x, which is what I'm trying to find. So I can use my calculator now. 9.6 times by, not sine h, that's a completely different thing. Sine of 61, close the brackets. X is going to be 8.40 centimeters rounded to 2 decimal points. That's how you find an unknown side. But there's a reason why I want to show B next. So can you get that first example for A, how I find an unknown side? We used the sine ratio to find X. Is that a Pokemon beam? That's sick. Pig. No, that's not Piggy. That's Eevee. Is it Eevee?
Yeah.
I knew the original 100. Now there's like 1,000. I can't remember all the names. Okay, why have I chosen this one to give as an example? Where's our angle? Do I know an angle and do I know a side in B? Yes, my calculator is already in the right mode, so I'm not going to waste time doing that. Let's label the side. 7.8 is opposite. X would be what? Would X be the hypotenuse or would X be adjacent? Adjacent. Which of the ratios involves opposite and adjacent? 10. So tan 41 degrees is equal to opposite 7.8 over adjacent X. So why did I do B? Because this example has X on the bottom. It's slightly harder. What's the opposite? I want to get rid of that fraction. I want to get rid of that divide by X. What's the opposite of dividing by X? Timesing by X. So if I times both sides by X, times this by X, it's going to be X times tan 41 degrees is equal to 7.8. There's an extra step here, basically. I don't want to know what X tan 41 is. I want to know what X is. So I need to get rid of the tan 41. What is tan 41 doing to X? Timesing. So what's the opposite of timesing by tan 41? Divide both sides by tan 41. That's going to cancel, so X is going to be, so on your calculator, I'll put on the other side. 7.8 divided by tan 41. 8.97 meters rounded to 2 decimal points. That's how you find sides using the trig ratios. So for the remainder of this double lesson, please, can you practice doing that? Get fast at it. In 12C, finding side lengths. And that's done.